A zvu tedy na pódiu kolegu Stafana Klingvalla z Planet Labs, který vás seznámí s těmito daty.
All right. Thank you, Inka. Thank you very much. So hello, my name is Staffan Klingvall. I come from Planet. Unfortunately, I don't speak Czech, so I didn't really understand the last presentations, but I saw the images. And this morning, when we started this conference, before Mr. Peter Seidel, introduced us to everything, there was sort of a commercial from Esri, a movie, where it says, "What do you want to see?" What do you want to see? And I selected this image. This is an image I would like to see. It looks like it's a healthy forest. It looks like it's a clean water stream. It looks like it's a good environmental picture. And I would like to see this image every day, not changing much. I would like to believe that this is the type of images we can constantly have, but unfortunately things are happening, things are changing around us due to conflict or environmental purposes, and a lot of things can happen in a day. But this was my mental image. But during a day, a lot of things can happen. In one day, crooks and thieves can build a road and steal a lot of trees somewhere, wherever, and then not only stealing the trees, but creating a carbon footprint that we haven't asked for, so they create double trouble by doing things like this. In the span of one day, we see there is conflict everywhere. A lot of things happen. In one day, an airplane can land or start from an airport, and it might be important information for many people to understand that. So in a day, a lot of things can happen. Also in a day, if you are a farmer, lots of things can happen with your field. There might be a drought coming, there might be a storm happening, there might be a disease coming to your fields, and you would like to know, is your image, is my image of my nature still valid, or is there something going on, so that you can take actions and hopefully save your crop. And I have this mental image of the first picture I would like to keep. If I can see that image every day, I will be sure that nothing have happened to it, if it's a real image, but I challenge you to think about what would you do if you can see a daily change of whatever that is. Your nature picture, or your field, or your lake, or your city, of whatever that can be. And at Planet, what we do is we provide satellite data daily. On a daily basis, we take photographs or images of the whole planet, and I will show you a little bit more how we do that. But it is a capacity that we can enable everybody, and I mean, you in the Esri community, you are the expert of analyzing images for creating answers to questions. We can provide you the data, and we can provide you the daily data over examples like this. And I will give you a couple of other examples on data and how this data can be used. Copenhagen University have done research on trees, counting trees. They actually found 29% more trees in Africa than we knew, according to United Nations statistics. There shouldn't be that much trees in Africa, but they actually counted every individual tree and found 29% more. They have done the same thing for India, identifying 600 million trees, but interestingly, what they also can see, because our data comes daily, which means that not only do you see what happened today, you see what happened yesterday and the day before and the day before that. And if you take advantage of this time series of data, you can see that it's not only in the forest that trees are disappearing, it's actually in the deforested areas that people are cutting down trees for whatever, maybe they need to warm up their house or cook food, or I don't know why they do it. But if you don't know this information, you can't take the proper environmental, protect your environmental in the best way if this is not what you intended to do with this type of trees. So the data source can be used for a number of various things. Another example is this: when you have a conflict, or you don't even have to have a conflict, how does your country do from an agricultural point of view? How does your country do from a forest point of view? Here was a study by NASA Harvest using our daily images to predict what would the yield be from Ukraine now when there is a war. How many fields can they actually access, and which means how much produce can they deliver to the market, only if they can, without any other complicated logistics, because they can't utilize the land area. Taking it a step further, which we are thinking about now, how of the current fields can they not go to because of unexploded ordnance or mines or things like that? If you take an image every day, we can't see landmines, it's clear, but cluster ammunition, they tend to not explode, 15% of them. And if you take an image every day, you see where there are new craters. You can actually help them to say, please don't go out there. There's a lot of things that this daily time series give you in terms of decision making and decision policy and decision processes, because you have to see it to believe it. And if you get used to that, if you process these types of data through the tools that you are the experts on, the type of decision making that you can provide your customers are completely different. So there's many different types of use cases for this, but and here are a few. Forest is clear, and actually here in Czech Republic, the forest is, you have been one of the smartest users of our data for forest monitoring, so I will give another example a little bit later. But how do we do it? So we actually have a satellite with us. If you want to come and see our little booth outside, that's a real satellite, so we brought a real one. If you want to see, we design them, we manufacture them ourselves. We don't have rockets, so we have to ask for help to get them up to space. But then we sort of put them in a rotational pattern, like you see this, and combine it with the Earth movement. We can actually, with around 200 satellites, we can take an image of every part of the planet every day. So this is sort of how it works. I'm not a space expert, so don't ask me any technical questions about this, but this is this is how it works. Another example of daily data and the data set it creates. Because there's a reason for us wanting to understand environmental impact. Maybe we work with city infrastructure, maybe we work with healthcare, maybe we work with something where we want this data, but the reason we do it is to take care of our population. We want our kids to be safe. We want to have as close as we can to hospitals and schools. We want to make sure that there's enough water supply for us to drink and for our agriculture. So there's a lot of things we want to do. And here in Prague and where I come from Stockholm, we have good knowledge about who is living here. We know roughly how many houses there is and the population, because we track it and measure it digitally. But not everywhere they do it. This is a town called Zinder in Niger, 2012. And this is how it looked like. And then they did the population calculation 2012. And they have not done it since. And then this town, for some reason, is growing with up to 15% per year. And now it looks like this, 2023. But what have we done? We have, because we have these satellites and they are up there since 10 years and they take this image every day, we worked together with Microsoft and said, can you help us do a sort of a building detection algorithm? Can you analyze these images that we now have so we can show the authorities and they can understand how much more population do we think we have, how many new houses have been built during this period. And here is the answer. You know, during this 10-year period, the town grew exponentially. There's so many more inhabitants here. We don't know exactly how, but here are all the new constructions. Here are all the new buildings. And this data set now can be shown to people who should plan what happens if there is a fire, what happens if there is a disease coming. Do we have hospitals? Do we have transportation routes, food supply, schools for our children? You know, how can we assess the size and the needs of a city when we don't do, you know, modern digital population counts as we might do here or in some other cities? So the data set can be used also to plan and prohibit things to happen before it happens. I'm trying to press. So here is a sequence of events over one specific area. You know, if you are the owner of this harbor, or if you are a traffic planner for this area, or if you handle the freights, you will understand the importance of these types of time series. And for every part of the planet, over Prague here or over the city where you come from or anywhere, we have roughly 2,000 images that you and your team could use as a data base for analysis. And we believe that this type of data, you know, we are a data provider, so we feed the ARCGIS platform and the tools with data so you can do all this analysis, can be pretty important for a lot of aspects. You know, for instance, you know, we want to do a green transition. We want to put on the table proof and evidence for that we do actually have an effect. You know, if you talk to a multinational food company and they tell you that, yeah, we have replanted 100% of everything we took out from this forest, it's now very easy to validate. You just have to ask them, so where is your palm oil plantation? And we can go there and ask for an image. You know, we can actually challenge people much harder. We can use the data set for students in the universities to ask them, develop new analysis models for us. Use this for your machine learning classes. Use it for your AI development. Use it to build the curriculum for GIS, you know, base course 1, 2, 3. So the data set can be used for a lot of things. And of course, for me, you know, environmental protection and environmental mapping is very important. I would like to see my image stay like that and have and be able to react if it doesn't, in a way that I can put the truth in front of people that makes decisions. You know, so we can sort of analyze the optical images in a way that, you know, we see things and then it can give us a static truth. But if we do it consistently over time, it can actually also help us make decisions and project things that can happen. So the images is what we give to you, but half of our business is to design these small gadgets. The one that we have with us today is one of these, so come look at it. No, it's not bigger than this. It's a shoebox size. We have sort of 200 of them in space, and those is the one that gives us the daily cadence, 3-4 meter resolution. And then we have the other SkySat that I heard you mention SkySat a couple of times in your presentation, so we have a number of those. We are now sending up a new fleet of satellites that can give you 30 centimeter resolution, but up to 30 visits per day. So things are sort of getting interesting now with all this capacity that we have. But for me, the ones to the left are sort of the most important ones anyway, because we can monitor the planet every day. We can monitor your country. It sort of runs on its own. We are sending up, I think, 20 new ones this week, to complement. It happens that they actually burn up, or it's actually intended that they burn up when they are done. And soon, I don't know when, we go into this hyperspectral tasking, which means that we can start visualizing things like methane gas and other materials and minerals in a completely different way, which also help us to see patterns of, I don't know, oil fields and gas and other emitters that we want to guide to do it in a more environmental way. We have at Planet a very comprehensive university program. It's not so known, but it's getting bigger and bigger. I think last year this number of papers went up to sort of almost 900 papers per year written about something that they used Planet data for. So if you have an interest, Google, I think you have done it, building detection, Planet scope, or forest monitoring, or bark beetle detection, which came from the University of Prague now in May, I think. It's a fantastic paper, how the Planet data have been used to detect forest health, and how forest health can be related directly to these bark beetle attacks. And sort of, I'm kind of new to this business. I thought, forest and agriculture would be the main, research topics, but no, water and ice seems to be really big topics. Arctic monitoring, I couldn't imagine that, but there's a lot of things happening that is not directly related to overland issues. So I wanted to give you a little bit of a visual picture of, my environmental image, but you have your own. And if you think about what it would mean to you and your management or your country's management to be able to track what is important over a time series, maybe you can consider, because you have the tools to do it, we have the data, and maybe a combination of that would be pretty successful, to utilize. And I wanted just to inspire you a little bit to check this out. We have everything. We store petabytes of data every day. Come and have a look at our little Dove satellite outside here. We are in the far right corner. And yeah, thank you very much.
Thank you, Stefan. Máte někdo dotazy na pana Stefana nyní? Tak já asi poděkuju, a kdybyste měli zájem o další dovysvětlení nebo nějaké další dotazy později, tak samozřejmě Planet má stánek vedle stánku ARCDATA, můžete si prohlédnout i tu družici, kterou přivezli. Takže já děkuju, thank you, Stefan.